Hi, my name is Daniel Gottschall. I'm with the Mathematics Learning Resource Center, and this is my third video on the equation of an ellipse. Alright, so in this video I'm going to introduce what the foci points are for an ellipse. Uh, I'm kind of going to do it in an abstract way, but I think it'll become clear. Maybe not when I first say the definition, but just bear with me and see how I work with them. And I hope by the end of this video you'll really understand what the foci points really mean. Uh, so I drew a horizontal ellipse here. And you see I have my center HK, my four given points that we talked about a lot in the first two videos. But I also added on these extra 2 points. And what those are the foci points on a horizontal ellipse. You can see how they sort of, you could think of it almost as the horizontal axis of the ellipse, so to speak. Uh, Note on a vertical ellipse, I drew it here. Our foci points are on the, so to speak, the vertical axis of the ellipse. I'm going to work with the horizontal ellipse in this video, but all the results can be easily extended to the vertical ellipse case. Okay, so what are these foci points? Okay, so the formal definition is given any point on this ellipse, let me pick here. If I add up the sum of the distances of the distance from the point on the ellipse to one foci point plus the distance to the other foci point, the sum remains constant. Uh, I'll say that again. So given this any point on the ellipse, if I take the distance from that point to h plus c comma k, add on the distance from the ellipse point to the point h minus c comma k, add up those two distances, it'll always be the same number, no matter what point I pick on the ellipse. If I do it here and do the same thing and so on. Uh, okay, so you might know what I'm talking about. If not, don't worry, because I'm going to be working with them. Uh, because I want to discuss how to find a formula to calculate what the foci points are. And we use this fact, like how they're defined, that the sum of the distances remains constant. So notice here, let's pick the point h plus a comma k, and I want to find the sum of the distances from that point to both of the foci points. Uh, so first, if I look at this distance to the closer focus point, what is that distance? Well, the y coordinates are the same, so the only distance measures can come from the x coordinate, and that distance would be h plus a minus the x coordinate of the focus point, h plus c. Hopefully that's clear. And then if I want to add on the distance from the h plus a comma k to the second focus point that I drew the distance in orange, that will be LH plus a, and then we're going to subtract the other x coordinate, minus h minus c. Okay, so this would be a rehash. This is my blue distance from h plus a comma k to the first focus point. This is my distance from h plus a comma k to the other focus point. And I want to take the sum of these two distances to get a number, or a letter. In the concrete cases will be a number. And if we do this math, we'll see that it basically just comes out to 2a because everything else cancels. You can check that. Because you'll have h and minus h in the first term, h minus h in the second term. You'll have minus c in the first distance, plus c in the second distance, and then you'll have a plus a is 2a. Okay, so that's how sum of the distances, and no matter what point we pick on the ellipse, the sum of the two distances is always going to be 2a by definition. So now let's focus on the point, sorry, it's a bad word. Let's think about the point here now, h comma k plus b, well, we know that, let me pick a new color here. Okay, so we know that we add the distance from the point to one focus point plus the distance from the other focus point. It has to be 2a. Now also notice you sort of have to just see this geometrically, but uh, the distances have to actually be equal. Why is that? Because, well, we could think of it, you may think of this as a triangle and sort of see that the top of this triangle is the midpoint of the bottom line segment. So thinking in terms of the x coordinate, it lies right in between the two foci points. Another way you could think of it is we're going from h to h plus c, so with respect to the x coordinate, those c apart, and same with h and h minus c, those c apart. Um, and then the height is also the height difference is also the same. It's actually a height of b. So without actually calculating the distances, we can, because we know the sum of the distances has to be 2a and that these two green lines have to be equal, we can just simply say that each of them has to be a. Hopefully that's clear. Alright, so why do we care about this? Well, because now focusing on the right half triangle, so this one, this actually gives us a direct formula for calculating c, because we know this is length c because we're going from hk to h plus c comma k. And of course this has height b, going from h comma k to h comma k plus b. That's a right triangle, so we know by the Pythagorean theorem that we must have the hypotenuse a squared equals the square root of, sorry, a equals the square root of b squared plus c squared. And we can rearrange this to solve for c. That would give us c equals the square root of a squared minus b squared if you do the algebra. So that's a direct formula for calculating. So given an equation for an ellipse, we know what the a and b are. We can easily find c, and then we also easily know h and k from the equation of an ellipse. So that gives us the two coordinates for the foci points. And if you do the similar thing, you can with the triangles, it would be the same idea for the vertical ellipse. But if you walk through the algebra, you would see that the formula for calculating the c is the square root of b squared minus a squared. You can try that if you want to practice. So those are two formulae, depending on what case we're in, if a is greater than b or b is greater than a, how to find the foci points. Alright, so that's pretty much all I want to say about that. The other topic I just really wanted to talk about really quickly to wrap this video up is eccentricity. So here with the horizontal ellipse, that's defined by E equals C over A, where E is the eccentricity. And it's basically just a measure of how circular the ellipse is. So the rule is as E approaches 0, we get a perfect circle. And you can, this is true because using our definition up there, because C equals the square root of a squared minus b squared. If we're saying E is 0, that implies C is 0. And if we do that, we would get that A has to equal B, which of course is, because remember A and B have to be positive numbers, so we would have A equals plus or minus B, but then they both have to be positive, so we can just say A equals B. And that's, remember, you may remember from video 1 on the equation of an ellipse that this implies that we have a circle. You could double check the beginning of that video if you want. We discussed that before, so I won't go through that again. And then as e approaches 1, we get a flat line. Uh, and this is true because if e is 1, that implies that a equals c. And then going based on that formula, c equals square root of a squared minus b squared. I'll substitute a for c, and then I'll get, you basically have taking the square of both sides at the same time. You can kind of see here quickly that b has to be 0. Uh, And then if we look at back, what is the definition of B? That's essentially the height, or I should say half the height of our ellipse, because it goes from minus B to plus B. So if B is 0, we can see that this ellipse would, the height would collapse essentially, and you would end up with just a horizontal line. And again, the eccentricity can be expanded to the b greater than a case, except that the formula is c over b. And same thing as e approaches as 0, you get a circle. As e approaches 1, you would get a flat vertical line in that case. Again, you can check that for yourself if you want. So yeah, those are just some other neat features about ellipses. I hope this video helped. As always, thanks for watching. Bye.